Lemmatization. Lemmatization technique is similar to that of stemming. The output we will get after lemmatization is called the lemma, which is a root word rather than the root stem. The output of the stemming. After lemmatization, we will be getting valid word that means the same thing as the stem. But note that the validity of the word is compared with the words in the dictionary. So, for example, if we have the word as octopus, through stemming, the stemming recognizes the last letter, that is the S, as a plural symbol and hence removes it, and the stem word would be OCTOPU. But factually, there is no such word in the dictionary. Hence, through lemmatization, this entire word, let's take a different color, this entire word octopus will be the lemma. It will first look for this, make this the lemma, and search if such a word exists in the dictionary. But in the dictionary, there is no such word, and there is no space after the U. There is an S in fact. Hence, this entire word will be taken as lemma. NLTK provides word net lemmatizer class, which is a thin wrapper around the WordNet corpus. This class uses morphe function to the WordNet corpus reader class to find the lemma. Let us understand it with an example. As we have previously discussed, the first two steps are pretty common: importing the natural language library, followed by importing the package from the library. Here we will be importing the package WordNet lemmatizer. Then we create an instance of that package. Now we call that package the word eating, and the output is eating. Notice how the ending word ing is not eliminated by the lemmatizer, whereas it was previously eliminated in the while using the stemming algorithms. And similarly, we apply lemmatization on the word books, but here the additional S is considered as an extra letter, and the word book is found in the dictionary, hence it is extracted and as the lemma. The increase the increasing size of data and information on the web is at an all-time high currently, for the past couple of years. This huge data and information demand necessary tools and techniques to extract inferences with much ease. Stemming is a process of reducing inflected or sometimes derived words to their word stem, base, or root form, generally a written form of a word. For example, as we've seen before, that stemming applies the cutting of the suffixes and the prefixes if necessary. So after applying a step of stemming on the word, it becomes a root word with after removal of the suffix and prefix. Lemmatization, on the other hand, usually refers to do things with proper use of vocabulary and morphological analysis of words, normally aiming to remove inflectional endings only and to return the base or dictionary form of a word, which is known as a lemma. In simple words, lemmatization deals with lemma of a word that involves reducing the word form after understanding the part of speech or context of the word in any document. Let us see the differences between stemming and lemmatization. Stemming produced by stemmers. Stemming is produced by stemmers. Lemmatization is produced by lemmatizers. Produces Stemming produces the words stem or the root. Lemmatization produces the words lemma, which in turn checks the root word if it's present in the dictionary. Now, stemming forms the root of the word. For example, if we take the word am, I am cannot be cut down into a shorter form. You cannot remove the m, nor can you remove the a. Hence, it remains am. But with lemmatization, am changes to a different form, be. Now, if the sentence is I am building a house, and it has to be changed into third person. In English, we would say that he is building a house, but that changing from am to is takes place through the lemmatization. And the root word for am, is, was, etc., all of them is be. Hence, be is taken as the lemma. Now, if there is a typo, for example, the goin, or we can say he is is goin, is going there. Notice how the word goin consists of just Goin, similar to the example in this table. When goin is input to a stemmer, it forms the root word that is go. But on the other hand, where if we give the word goin, the same thing goin to the lemmatizer, the going becomes going because there is no word such as goin, and the closest word to going is going. The left portion here, as you can see, the left portion, as you can see here, is the result of stemming the word go in. And the right side, the word going is the lemma of the word go in. Similarly, we have for the word having. Now, this is an interesting example. The word having, when given to a stemming algorithm, it removes the suffix ing and we have the word HAV. But when we give the same word to the lematizer, having, it removes the suffix and checks if the word has any meaning. That is, it compares the root formed with the words in the dictionary. Since there is no existing word in the dictionary which spells as HAV, the closest word to this is given as the lemma, that is HAVE, have. Difference between stemming and lemmatization. Let us understand the difference between stemming and lemmatization with the help of the following example. After importing the respective package from the NLTK library, when we use the Porter stemmer, the first stemmer we observed in the previous video, believes, the word believes becomes believe without the E. But does that word make sense? No, it does not. But when we give the same word believes to the lematizer, it adds an extra, it holds the ending E and removes just the S. It separates out the S. Now, believe is a valid word existing in the dictionary. The output of both programs tells the major difference between stemming and lemmatization. Porter stemmer class chops off the ES from the word. On the other hand, WordNet lematizer class finds a valid word, that is, a removal of the suffix S and not the suffix ES. In simple words, stemming technique only looks at the form of the word, whereas lemmatization technique looks at the meaning of the word. It means that after applying lemmatization, you will always get a valid word.